Hello data voyagers, I am Igor Alcantara and I am here to show you a problem that I was working the other day, and then I thought, well, I think other people might have the same problem, so why not show them? And the problem is, how do I calculate the distance between two locations given just the longitude and latitude of those locations? So that's how I'm going to show you, not on a map, but in an actual data module in Qlik. So here's a problem that I have. I have two locations or two locations data set. I have drones location, so I know it's cloudy, but these are all like the drones that we are observing on the US map. And then I have right here some secure locations. Locations like, for example, military bases, airports, government buildings, power plants, locations where civilian drones were not supposed to fly nearby. So if I take a state, let's take Georgia, for example. So in Georgia or close to Georgia, these are the drones that we capturing, and these are the different secure locations that we are observing. So, but how do I know if the drones are flying close without just looking at the map? Because the map, they might be look at close, but just because of the zoom level, it's so low, then it might give the impression that might actually be the truth. And how close, how many kilometers, how many miles? That's what I want to try to calculate. But before going to how we do it, let me just quickly show you the data we have. So we have the flight data, a lot of data, but what is important is we have the latitude and longitude. And we have the secure locations data, again, a lot of data, but what is important is the longitude and latitude. So those longitude and latitudes for those two data sets is how we define where they are on the map. Now, how do I translate these to an actual distance? Well, let's go and analyze a little bit of theory. Let's talk about theory a little bit, but just a little bit. Don't be scared. We're not going deep in math. No worries. You don't need to remember or memorize any trigonometry. But let me give you a spoiler. Actually, not a spoiler, because it's something we know for thousands of years. The Earth is not flat. So calculating the distance between 2 points, let's say points P and point Q, is not the same as calculating a flat distance, just like you're doing on a surface, like on a small surface, for example. We need to calculate the distance in a sphere. So that's the problem we call the great circle distance. So look at this. We want to calculate distance between points P and Q, but in a sphere. And how do we do it? Well, we use trigonometry, but a special kind of trigonometry. And what we are provided in terms of input is, you can see right here in blue and in red, are the angles of longitude and latitude. All right, so the angle of longitude and latitude, and that is important. For that, we need a concept. We call it the versine or the verse sine, which is just a fancy term for 1 minus cosine. Why is that important? Don't worry about it. If you want to understand it more, you can Google it and you can do your own research. But let's focus on how we do this in Qlik. But just a little bit of theory. So for that then, to solve the problem, and it's very common in navigation, we need a formula, and it's called the Haversine Formula, which is a formula who was first used by this guy right here, the Spanish mathematician astronomer named José Mendonça Ríos. He developed this in 1801, and he did not give the Haversine name, but which is basically means half a verse sine. So verse sine is this, half of that, Haversine formula, which is this complex formula here. I've seen people trying to implement it like verbatim, just like as is, but honestly, we can simplify that. But there's one important thing about this formula. All of the angles are provided in radian, which is not how we have it in Qlik. So we needed to convert to radian. How? Simple. You take that value, multiply by pi, divided by 180. So that's why in this formula here, this is how we implement it in Qlik. USC times pi divided by 180 a few times. So that's how we calculate it. And I did my calculation in kilometers, but I'll show you how you can do it in miles as well. Why in kilometers? Well, one reason. It makes sense. It's a logical unit of measure. But anyway, I'm not going to get you like complex discussions, but it's my choice. But if you want to do miles, it works as well. Great. Now, how do I implement it in Qlik? Well, just this formula. Let's take a look at this formula a little bit better. So basically, I have the inputs are longitude and latitude for those 2 points, P and Q. So P latitude, Q latitude, P latitude, Q longitude, etc. So pretty simple. But instead of P and Q, I have flights and secure locations. So easy. Do you have to memorize this formula? Write it down. Pause this video. No. If you go to datavoyagers.net, I'll have a blog post about this specific video, and I'll have the formula there. You just simply copy and paste, and then you implement it in your solution. So how do we do it? Well, let me go step by step so we better understand. So first of all, because I want to do a calculation using 2 different data sets, I need to get those data sets into one table. I need to get them together. And I don't care if they're in the same state or not, so I just want to get them together. So what I want to do to start is to create a Cartesian product, which is, in other words, I'll have a table with all possible combinations between those 2 data sets. In other words, for every flight, I'll have all of the secure locations, regardless if they're closed or not. So it's basically you load one table and you do a join with the other table. So no inner join, left join, right join, just do a join. You get a very large table. So let's run it. Don't mind the circle of reference. It is not the final solution. But let's get here. So that's the Cartesian join. Look at the number of rows. Hundreds of thousands of rows. But if you look at flights, it's less than 1,000. If you look at secure locations, it's less than 250. And then because we're doing all possible combination between those choose, then we have this large table. But it's okay. It's only temporary. Now, once we have that, then I can calculate the distance. Now, how do I do the distance calculation? Well, it's just that formula. I have that formula here as a comment, and then I just replace the P and Q values to the actual field names, like flight latitude, or secure location latitude, or the secure location longitude, and the flight longitude, and so on. And don't forget to multiply by pi divided by 180. I'm using the variable to store pi here, but you could simply use the pi function. It's all the same. I'm basically storing that in the variable. Why? Just because I want it. And then you run it. How do I know this will be in kilometers? Well, you just multiply that by the whatever great circle radio is. So if I'm providing the Earth radius in kilometers, then I'll get my answer in kilometers. If I provide it in miles, then I'll get it in miles. So if I run this, again, don't mind that. It's a temporary solution. So of course I'll get a synthetic table, synthetic key, but again, it's temporary. But for every single flight and location, I get the distance between those 2 points. And I just calculated both in kilometers and miles. So you pick and choose. Great. Now, that's not what I want. I don't want to know, because it doesn't matter to me to know the distance between a drone in Georgia to a secure location in Oregon. They're too far away, so it's not a concern to me. So what I want to get is what is the closest secure location that each drone flew to. So let's say drone number 1, the closest secure location was the Atlanta airport, and the distance was, I don't know, 10 kilometers. So that's what I want for one value per flight. How do I do it? Very simple. So I read resident that table, and I basically group by the flight, and then I get what is the minimum distance. and then I get the minimum distance. And how do I get what is the location name and type for that distance? Well, we can use first sorted value function, which is a very useful function. I use it a lot for this type of situation. You do that, then you provided what column you want to get the value, and what the sorted field you want to do, which is a distance in kilometers. And then we do that, and then you're good to go. So let's run it to see the final result. Okay, so the final result is a table with the closest location. So for every single drone flight, I have what is the closest distance to a secure location we flew, what is the location, what type of location. So like this one flew like 59.7 kilometers to this airport, for example. Okay, and that's how you do it. Very simple and easy to implement. Again, I'll post the code in the datavoyages.net blog. And if you like this, please make sure to share it to your friends. Make sure to subscribe to our YouTube channel, so you can search for Data Voyages YouTube channel. All the links are in YouTube or on the Data Voyages blog. And if you really like this and you want to support our work, you can support by going to our store. So if you go to datavoyages.net and click the link store, you'll see the projects we're selling. We have like t-shirts, hoodies, mouse pads, mugs, water bottles, very good quality. And that money is used to support like the servers and website and the initiatives we're doing. All right. Hope you like this. Goodbye. See you next time.